Namaskar. So let's see how we can interface an EEPROM to a microcontroller I2C. Okay. So we studied already what are the I2C lines in microcontroller and how we can assign those pins and how we are taking out this I2C SDA line and I2C SCL line, right? So we are finished with our microcontroller pin assignment, right? Now let us just open one EEPROM. So I have selected one EEPROM for you, which is 8 kilobit EEPROM from ST Microelectronics. So this ST Microelectronics EEPROM is M24C08. Okay. If you want to reduce the memory size, then you can go for 04 also, not a problem. And this is very good package. 8 SO package is there, SO8 package is there, and the temperature is around -40 to 85 degrees centigrade. So let's open the data sheet first. So once we see it has I2C bus, okay, and some of the features are like it has 4 kilohertz, 100 kilohertz compatibility. Then the size, as I already told you, 8 kilobit. It has different supply range voltages. Like dash W will be 2.5 to 5.5. So for 3.3 volt and 5 volt application, this is good. So let me open the data sheet. It will be easy. So as you can see, both the speeds are there, then the memory size is there. This will be good for your, a 3.3 volt and 5 volt application. This is very good one. It can be useful for 2.5 volt as well as 3.3 and 5.5 volt also, right? You have another, F series, okay? So based on the, availability of your size, I would suggest you can go ahead with that, right? So if you need very compact one, you can go ahead with this or this, okay? And if you are working with a very, a big PCB, then SO8 or TSSOP8 is good one. So I am going to take this SO8 package, all right? You can see right within 5 millisecond, and then temperature range as already mentioned, like -40 to 85 degrees centigrade. 0 to 70 degrees centigrade also is there, okay? So but that will be consumer application. You want industrial application or something, you can go ahead with this, right? So keep in mind SO8 package, uh, 0 M24 C08 R series, okay? And the very good thing is it has enhanced EST protection. It has more than 4 million write cycle. 4 million means 40 lakhs, okay? So you can write and write, 40 lakhs times, erase it and write it again and again. And the data retention is around 200 years. So it is very good one, right? Let us quickly see what are the, pins. So E2 is chip enable, SDA is serial data line, clock line, write control. So you want to, control it, like whether you want to restrict users from writing. So you can use your write control pin, and this is supply pin and VSSC. Okay. So once, our aim is to understand chip enable and write control. That's all. These two lines are there, which will be needed to understand what are their functionalities. Okay. So as you can see, serial clock line. So serial clock line is input. So you have to give microcontroller SCL line to this clock line. So it will be an input clock to the EEPROM SCL line. Okay. The microcontroller output, as I have mentioned here, see here, the microcontroller clock line going to go to as output to the input of SCL line of the EEPROM. Okay. Similarly, I will show you in the data sheet how it works. So this is ground. This is my VCC, which is going to go to VCC line, and this is a capacitor which will be, let's say 10 nanofarad to 100 nanofarad. Any value you can keep. So I have kept it a nominal value of 33 nanofarad. You can keep 47 nanofarad also. This will be a good value. Okay. I can provide you the part number as well for this, right? Coming to the fact that E2 was enable line. So if you want to control the enable disable, then you can keep a GPIO over here, okay, and once you pull it high, then it will be enabled, like it will start working. You pull it low, then it will stop working, okay. So I have permanently pulled it high so that there is no need of like enable disable. Coming to the fact that right like control, so right control, if you pull it down, okay, then it will always work, okay. So keep it not connected or connected to ground, okay. So there is no need to use another GPIO for controlling this. Or if you want to stop users to write this, or you want to protect your device, then you can use a write control line. And once you make it like high, then what will happen? It will not allow to work, okay. Next, once you make it low, then it will start working, okay. This is how you can do. So for this write control, what I can do is I can use one of the GPIO line. Let us say one deep switch I will remove and I'll put WR control, okay. So this WR control will make sure my write enable disable is done. So let's see the data sheet and quickly understand. I told you SDA line, then chip enable. Chip enable, you can see that this bit is tied to VCC or VSS, okay. To establish the divide select code, okay. So when not connected or left floating, this input is read as low, okay. So you can see it has been connected to VCC or connected to ground. All right. Write control, you can see either drive it low or left it floating, okay. If you drive it high, then what will happen? The bytes are not acknowledged, okay. So you will not be able to write it. Or you can see entire memory when operation is disabled, operations are disabled when you drive it high. So you do not drive it high if you want to write it, okay. That's it. Coming to the fact that operating I mean ordering information. So let's see. In the ordering information, you can see here you have M24 series, which is I square C lines, okay. Then C08 is 8 kilobit, okay. If you want C04 also you can use, okay, which will be 4 kilobit. R series I am using, which is 1.8 to 5.5, okay. And your package will be MN, which is SO8, okay. And this is industrial grade, which is -40 to 85. And this is tape reel I have kept. And sorry. So if you want to write down a part number completely, then what will happen? M24 C08 dash, instead of W I will write it R, then I will write it SO8, that is MN, okay, then 6, okay. And this will be TP, okay. So that's it. You can see T for tape and reel, and P or G, so G is equal to ROHS and halogen free, okay. So if you want to write down, then TG also you can use, okay. And dash T, last one is manufacturing technology code, okay. So TP dash T, this is a complete part number. Let us continue to the circuit design. So circuit design, what I did is I already pulled it up 4.7K. This is my SCL line, and 4.7K, this is my SDA line. So since I have pulled it up here, so I have removed my pull-up resistors from like a microcontroller side, right? So that's the reason I have put it DNP. So do not put both the places like pull-up resistor, otherwise they will get like a parallel combination, and the overall value will get reduced, okay. So use at only one place. So if you are using here, then you don't have to use here, you have to remove them, okay. But anyway, I have put it here, so I will keep it. All right. Next, write control, I told you that this will be a input line from the microcontroller to this EEPROM. So write controller, it will go high, then the EEPROM will be disabled. When it will go low, then the EEPROM will be functioning normally, and you can read and write both. Okay. So hope you have understood how I can interface my microcontroller I2C lines to an EEPROM. Okay, and this EEPROM will be very easy to write it, and it has very good capacity as well, 8 kilobit, which will be used in your consumer applications like BP monitors, or maybe temperature sensors, okay, or temperature reading devices, okay, or maybe any other functionalities there you want to like write down your continuous data or live data, right? So hope you have understood. If you do have any questions or any other like queries, you do write your like questions in the comment box, and I shall be able to answer you out. Thank you.